Hello and welcome back to my GCSE Science. This chemistry video is about factors affecting equilibrium. Hopefully you've just watched the previous video on reversible reactions and equilibrium, so that it's fresh in your mind as a good starting place for this one. In the last video, you learnt that if a reversible reaction is in a closed system, meaning that no reactants are being added and no products are being removed, then eventually it will reach a point of equilibrium when the rates of the forward and the backward reaction are equal. Although both reactions are happening at the same time, there's no change in the amount of reactants and products because both reactions are happening at the same rate. But that doesn't mean that there'll always be an even amount of reactants and products. And the amount of reactants compared to products at equilibrium depends on the conditions of the reaction. If a system is at equilibrium and a change is made to any of the conditions, such as concentration, temperature, or pressure, then the system will respond to counteract the change. This is called Le Chatelier's principle. Let's have a look at how it works for each of the different conditions. First of all, concentration. If we have a reversible reaction such as A plus B makes C plus D, A and B are the reactants and C and D are the products. If we were to increase the concentration of A, one of the reactants, then Le Chatelier's principle states that the system will respond to counteract the change. So if we've increased a reactant, then the system will shift to decrease the concentration of that reactant. Can you tell what's going to happen? Well, if we've increased the concentration of A, that means we've given the reaction more particles of A. This favours the reaction in the forward direction from left to right and creates more products of C and D and uses up more of A and B, the reactants. By giving the system more particles of the reactant, it causes the forward reaction to happen at a faster rate than the backward reaction. While this is happening, of course the system is no longer at equilibrium because the rates of the forward and backward reaction are different. But eventually equilibrium will be re-established, but the position of the equilibrium will shift towards the right, meaning that there'll be relatively more products C and D compared to reactants A and B than we had at the beginning before the concentration of A was increased. And the same applies in the reverse. If we were to increase the concentration of one of the products, such as C or D, then the backward reaction would be favoured, producing more reactants, using up more products, and shifting the position of equilibrium towards the left. As we said in the previous video, in all reversible reactions, the reaction going in one direction will be exothermic and the reaction in the other direction will always be endothermic. They'll always be the opposite of each other. And what happens to the reaction when you change the temperature will all depend on which direction is exothermic and which direction is endothermic. So in the exam, when you're talking about temperature and its effect on equilibrium, it's important to always talk about which direction is exothermic or endothermic. In this reaction, we have ammonia gas and hydrogen chloride gas reacting together to make ammonium chloride, which is a solid. You might have seen this in your chemistry lab as an experiment where you have a long tube and you put either gas on either side and it creates a ring of smoke somewhere in between the two ends. When the two gases combine to make ammonium chloride, it's an exothermic reaction. You can also heat ammonium chloride to break it apart back into ammonia and hydrogen chloride. This means that the forward reaction, as it's written here, is exothermic, releases energy, and the backward reaction is endothermic. It takes in energy from the environment. So what do you think will happen if we increase the temperature? Well, there's really two ways to think about this. The way that I think makes most sense is that if you increase the temperature, then the reaction that takes in the heat will be the one that's favoured. And that's the endothermic reaction, which in this case is the backwards reaction. It will absorb energy from the surroundings, and in turn it will cool down the system. This leads us to the second way of thinking about it, which is more likely to be the one that will be asked about in the exam. So use the first way to figure it out, and try and learn this next bit as a way of explaining the change. Le Chatelier's principle says that if a change is made, then the system will respond to counteract the change. So if we increase the temperature, then the system will react to decrease the temperature again. As we know from before, because endothermic reactions take in heat from the surroundings, they'll result in a cooling down of the reaction. So increasing the temperature always favours the endothermic reaction, and in this case, that's the backwards reaction. So we'll create more of the reactants, ammonia and hydrogen chloride, and less of the product, ammonium chloride, because it's being used up to do the backwards reaction. Perhaps you can have a go at explaining what happens when you decrease the temperature in terms of Le Chatelier's principle. Have you figured it out? Well, if you decrease the temperature, then Le Chatelier's principle suggests that the system will respond to counteract the change, meaning increasing the temperature. So the exothermic reaction, which releases thermal energy, is going to be favoured. And in this case, that's the Ford's reaction. So the Ford's reaction is favoured, which shifts the position of the equilibrium towards the right-hand side, therefore making more of the product ammonium chloride and using up more of the reactants, ammonia and hydrogen chloride gas. The final condition which has an effect on equilibrium is pressure. In a closed system, the pressure of the gases inside will be directly related to the number of moles of gas contained within it. You may remember, if you're on triple chemistry, that no matter what gas you have, 1 mole of any gas has the same volume, and therefore at the same pressure it will take up the same amount of space. Therefore, if we increase the overall number of moles of gas in a reaction, we would increase the pressure, and if we decrease the overall number of moles of gas in a reaction, we would decrease the pressure. Therefore, what happens in a gaseous reaction when you change the pressure in a closed system like this all depends on how many moles of gas you have on the left-hand side compared to on the right-hand side. Make sure you're clear that the left-hand side is the side of the reactants and the right-hand side is the side of the products. Using the balanced equation, we can see that on the left-hand side we have 4 moles of gas, and on the right-hand side we have 2 moles of gas. So we have more moles of gas on the left-hand side and fewer moles of gas on the right-hand side. Can you guess what would happen if we increase the pressure? Well, according to Le Chatelier's principle, if we increase the pressure in the system, then the reaction will respond to counteract the change, meaning it will want to decrease the pressure. Therefore, the reaction that produces fewer moles of gas will be favoured, as fewer moles of gas will take up less volume in the same container, therefore reducing the pressure. So in the case of this reaction, if we increase the pressure, the Ford reaction will be favoured because there are fewer moles on the right-hand side of the equation. This means that the equilibrium will shift towards the right and will produce more of the NH3 or ammonia gas, using up more of the nitrogen and hydrogen. This in turn will reduce the pressure in the system, therefore meeting Le Chatelier's principle. Of course, the opposite will happen if we want to decrease the pressure. Decreasing the pressure will mean that the reaction counteracts the change to increase the pressure again, thus favouring the backwards reaction, making more of the reactants and leaving behind less of the products. In the exam, make sure you always check that the equation you've been given is balanced, because any question relating to pressure and equilibrium will depend on the balanced equation, because the balanced equation tells you the number of moles of gas on either side. And that's it. Those are the 3 factors that affect equilibrium. Make sure in the exam that you always refer back to Le Chatelier's principle, and always state whether it's the forward or backward reaction being favoured by the changing condition. Here's a list of your keywords for this video. Thanks very much for watching, and see you again soon on another video by My GCSE Science.